So this is the grand test paper which we had yesterday. Division level grand test paper. Even in your computer screens also, you will see one question per display. In a display, you will see only one question. Right. So similarly, I have designed my display too. It is not that I have seen lot of students when they were starting examination. I have seen lot of you people. You start from the first question or whatever it is. Spend some time in the selection process. That is the first point that one should need to note. Therefore, I'll start my selection process first and then I'll solve the questions. Try to please remember when I am selecting questions, my first 5 or 6 questions need to be a clean hit. Suppose if my very first question selection itself stuck up and I am spending 10 to 15 minutes time on that. And by the way, while I am coming out of that 10 minutes or 20 minutes, I am unable to say that I could have solved at least some 2 or 3 successfully. That will show full impact on the rest of the paper, rest of the subjects too. That is the reason why what I suggest, even for a weak student also, there will be some questions which can be done comfortably. Right. Now, I'll start the question paper selection process work. Now, my time starts in my watch. It is around 11:35. Right. Let me see how many questions I will solve in a time of 1 hour. First question, doable. Second question can be done, but later stage. This question also doable straight. Next question also doable, but it will take time. Theory type questions straight. This is also a doable question. Not much of calculation is involved. It might, as my intention right now shows, it might take some time. It seems that it is a formula based question. I can do it. I'll do it later. This one also irrespective, I will do it later. Yes, I can do because it is from photoelectric effect. This one I can do. Easy question I can do. This can also be done, but it involves some calculation. I'll do it later. This can also be done, but bit calculation is involved. I'll do it later. This can also be done. H.C. Verma solved example. This is a lengthy question. I'll do it later. I can do it. Time. It will take some time. A formula based, I can manage. Simple, I can manage. Might take time, but I can do. It might take some time, but I can do. Yeah, this can be done, no issues. It may take some time. So this is my selection process. My first 4 questions, the valency of the impurity atom that is to be added to the germanium array N-type, P-type trivalent, N-type pentavalent. So 5. First question, clean it. That adds some positivity. The velocity of the liquid coming out of the small hole at the bottom of a large vessel containing 2 liquids here. Apply Bernoulli's equation across these 2 points. P naught plus P naught plus 2H rho G plus H 2 rho G is equal to half 2 rho V square plus P naught. So you cancel this. This is 4 rho GH and this is rho V square. So clearly V is equal to 2 times root GH. Second question, clean hit. Yeah, definitely that gives me some confidence. Clean hit questions is what I am looking at right now. Yes. The temperature of the gas contained in a closed vessel increased by 1 degree centigrade when the closed vessel means volume constant. That I need to understand here. When pressure of the gas is increased by 1%, so delta P by P is delta T by T, which implies delta T is 1 degree centigrade given. And honestly, you should convert this into kelvins. 1 Kelvin by T in kelvins is 1 by 100. Remember, T is equal to 100 Kelvin. Lot of students do mistake here by converting that 1 into centigrade and they will write 100 degrees centigrade, which is wrong. But the moment when I am applying this law, I know that I need to apply Kelvin because these are gas laws. 3 clean hit till now. Clean hit means clean hit. The VI characteristics of a diode is shown in the figure. The ratio of average, you already know, average forward resistance by average reverse bias resistance. Honestly, ideal condition, few ohms forward, reverse maximum. So honestly, that should be close to 0, very low. So this is not a possible number. This is not a possible number. Among these two, this is not a possible number. So this is possible. So therefore, 10 power minus 6. Otherwise also, you have some observation here. See, you can see that there is a difference of delta V by delta I is nearly around. Here you can notice delta V is 0.05. This is 5 into 10 power minus 3. So this will become 10 to the power of 5. Here delta V by delta I volts by current 0.05 by 5 times 10 power minus 3. In fact, this is 10 power minus 2, 10 power minus 3, 10 power minus 2, 10 power 3. So this will become 10 ohms. This is forward case. Look here, forward I took somewhere over here. In this case, for a small difference of 10 volt, there is a marginal rise of 1 microamps. So therefore, delta V by delta I is nearly 10 by 10 power minus 6. This is 10 power 7 ohms. This is a reverse. You take the ratio 10 by 10 power 7. This will become 10 power minus 6 ohm. But if I am good enough in the knowledge of this part, I will straight away mark 10 power minus 6. So 10 power minus 6 is the only possible option out of the given other 3 options. 4 clean hit. 4 clean hit. Now, right. The kinetic energies of the photoelectrons emitted from a metal are K1 and K2 when it is irradiated with lambda 1, lambda 2. Now, very simple thing is that Hc by lambda 1 is work function plus K1. Hc by lambda 2 is equal to work function plus K2. So you see, what is that you want in this case is work function, right? Uh, by the way, how you will get work function here? See, you have two observations here. One point is that you cannot eliminate work function here, by the way. So what you can do is take the ratio, that's all. Take the ratio. You will get lambda 2 by lambda 1 is work function plus k1 by work function plus k2. Lambda 2 work function plus lambda 2 k2 is equal to lambda 1 work function plus lambda 1 k1. I think you got the work function from this is lambda 2 k2 minus lambda 1 k1 by lambda 1 minus lambda 2. Got it. So I should do this. Now it is a clean 5 questions hit in a matter of less than 10 minutes. I am confidently that I have done 5 correct questions, and I'm even confident while doing this also. Okay. Yes, we need to start somewhere. Small body of super dense material whose mass is twice that of the earth, but whose size is very small comparable to the size of the earth, starts falling from rest from a height h very small when compared to r above the earth's surface, and reach the earth's surface in time t. Then time t is equal to. Please try to understand. In this case, a lot of people will do h is equal to half z. Wrong. You are not supposed to do that. So it's a bit lengthy question. I'll do it later then. Because while I am doing this overlooking, okay, fine, but it will take time. I'll postpone this because time is the criteria for me. Next, ball of mass m approaches a wall of mass m much greater than small m with speed 4 meter per second along normal to the ball. The speed of the ball is 1 meter per second towards the ball. You know, if a wall like object moves with VW, if an object strikes with the speed u, after bouncing back, it moves with a speed u plus tvw. You know this. Otherwise, do the question in the reference frame of the wall. Before collision u, after collision u, because elastic. Wall is a very heavier one. So therefore, obviously, what will happen? Velocity of the ball with respect to wall after collision is u. Velocity, sorry, 1 minute. U minus V wall before collision. After collision also it should be after collision velocity of the ball with respect to wall must more or less the same because it is elastic collision. In that way you will get velocity of the ball with respect to ground. But trust me, these things, if you are working in this sense, you are lost. These are standard formulas in collisions. If it is a wall heavy structure, if it is striking you with speed u and it is going up, going away, then it will go with u plus 2 VW. So therefore, in this case, u means 4, 2 into 1, 6 meters away from the wall. Clean hit. Next. The paths of electron and proton having same momentum are equally curved after entering perpendicular to the uniform magnetic field. 1 minute. Radius of the path of electron proton having same momentum. Radius is mv by bq. Remember, numerator is the same for both. Same radius of curvature for both. Maybe one is deflected, say leftward, the other might be deflected rightward, but the radius of curvature is the same. So that implies statement 1 is correct. The radius of the path of a charged particle in uniform transverse magnetic field is universally wrong. Radius is proportional to momentum. So statement 1 is correct. Statement 2 is wrong. It's a clean hit question once again. Okay. Next. Third question. The effective resistance between point P and Q of the electric circuit shown is, remember, R2R, R2R, 2R, R2R. This line becomes equipotential and no current splits in that direction. Suppose if this is a 2R, this is a 2R, this is a 2R, then picture is different. So this is a symmetric circuit for me. Since this is the current line of symmetry, this line will become the potential line of symmetry. So therefore, in this case, finally what will happen that I will say is 2R, R, 2R parallel. So it will be 1 by R plus 1 by R. That's the left hand part. Let this be 1 by R1. Let this be R1. Likewise, you have another R1. So your answer is, in this case, R1 is, yeah, in this case, R1 is capital R, small r by 2 capital R plus a small r. Likewise, you have two things. So A is the correct answer for this. 1 minute. 1 minute. Oh, correct. Correct. So what will happen is you will have 1 by 2 1 by r. This is the case. This is the case, right? Thank you. Right. Clean hit once again. An electron of mass me, initially at rest, moves through a certain distance in a uniform electric field in time t1. A proton of mass mp, also initially at rest, takes time t2 to move through an equal distance in a uniform electric field. What is the times? See, please try to understand. You said same distance. Half a1 t1 square is half a2 t2 square. A1 charges the same. Yeah, actually acceleration in this case is QE by m. Numerators are same. Only denominators is the factor. So 1 by mass of electron time T1 square is 1 by mass of proton times T2 square. So T1 by T2 is root mass of electron by mass of proton. So they're asking T2 by T1. So B is correct. In this question, make sure you check your answer twice, because in the fast process, you might even mark C. See, I have done T1 by T2. You will simply mark C, and thereafter you say that it's a silly mistake. Wrong. You have reached till the answer. This question should not go wrong. So how many questions I am correct till now? Literally? One. Okay, right. Next. Now let me work on other questions which I have marked. Let me just see. I have marked actually eighth. Eighth I have already actually marked. So therefore, eighth question I mark now. I need to do a small body of super dense material whose mass is twice the mass of the Earth, but the whose size is very small compared to the size. See what is happening over here. Let me see. This is the mass, point mass, and this is the Earth. This is 2m and this is m. The forces are same. See, forces are same actually. So the acceleration on this is the acceleration is, first let me find force. The force term is which is nothing but 2 mg. Remember 2 mg. So which means this will experience an acceleration of 2g instead of g. And also this will also pull this one with an acceleration g. So A relative is 3g. So S is half A relative t square. T is 2h by A relative 3g. This that you must identify. Next. Now onwards, I'll gradually lose options. So I need to be more and more careful. An electron of mass m with an initial velocity so and so in an electric field so and so. So what is the final momentum? The final momentum is m v naught I cap plus q e naught force into time of action t j cap. Fine. What do you want? The de Broglie wavelength at time t. So what is the magnitude of Pf? Under root mv naught square plus q square e naught square t square. See, if you wish, you can draw this mv naught out. In that case, this will become q square e naught square. You may ask me, how do you got this idea? You see, in 3 options, you have the same situation here. In 3 options, you have the same situation here. That should give you some idea on this. M square V naught square. So therefore, yeah, by the way, mv naught, wherever I say, I can write h by lambda naught times 1 plus q square e naught square t square by m square v naught square is p final. By the way, h by p final is de Broglie wavelength. So which is nothing but lambda naught by this. What is the difference between these two? What is the difference between these two? There is a root missing here. So there it happens sometime that you may even mark D instead of C. Please check twice your options. Right, 11th done, 12th done, 13th done. Now I am just like 20. I will try now. The temperature T at the junction, this is as same as theta 2 some R2 theta some R1 theta 1. This is potential difference. This is current times resistance. Theta minus theta 1 is again potential difference. Current times resistance. Take the ratio. R2 R1. No, that's all. So theta 2 R1 minus theta R1 is theta R2 minus theta 1 R1. Correct. Next, 51 done. Only tick marks I will check first. Thereafter, I will set. I'll enter into the rest of the areas. Hydrogen atom in its ground state is irradiated by light of wavelength 970 angstroms. And the ground state energy of the hydrogen atom minus calculate the number of lines present in the emission spectrum of hydrogen atom. Only thing that you need to do is when will you get 970 angstroms? For which transition you will get 970 angstroms? See, it is as same as 1 minute. 1 by lambda is R times 1 minus 1 by n square. If you know n, you will come to know the number of lines. How? If it is, for example, 3, you will get how many lines? N into n plus 1 by 2, 6. Likewise, you need to identify which transaction it is. See, how to identify that is HC by lambda is RHC times 1 minus 1 by n square. Only thing that is a challenge for me is we require this n square term badly. Or can you please give me, earlier I used to give you one relation. What is R in angstroms? R in angstroms. 1 to? Okay, 1240 by 970. Can you please tell me how much amount is this? If it is 12.09 plus, then you know clearly, nearly 12.8. So it is corresponding to n to 1, n is equal to 3 to n is equal to 1 transaction. So this involves how many lines? Prayer Pakka, sure. Just please cross check. It is not 3 to 1, it is a 4 to 1. Why? Because I will explain once again. If it is 2 to 1, it is nearly 10.2 electron volts. If it is a 3 to 1, it is 12 point some 0.5 approx. If it is a 4 to 1 only, it is a 12.7 something. So actually it is not 3 to 1, it is a 4 to 1. If it is a 4 to 1, 4 into 4 minus 1 by 2 number of lines are possible in the emission spectrum, which is 6 here. Okay, there is no other option for you. Now you need to go for all the questions from hereafter. The time is at 12 to time what when I have started this 12:45. So and then 11:35. Now whatever the time available, I need to go for a clean hit. Whatever possible, clean hit. Right. 0.1 kg mass is suspended from a wire of negligible mass. The length of the wire is given, cross-sectional area given. The mass is pulled a little in the vertically down and released. First of all, YA by L is the force constant of the string. You know this. The force constant is Young's modulus is what I need to find, right? No issues. No issues. So in the time period of oscillation, omega is root k by m. So k is omega square 140 into 140 by mass. into mass, 1 by 10, 0.1. So, by the way, hold on. K refers to YA by L is 14 into 10. Okay, Y is length. How much is the length of the wire? 1 meter, 14, 10, cross-sectional area. 4.9 into 10 power minus 7. See, these are big numbers. Handle it carefully. 4 into 49 into 10 by 49 into 10 to the power of minus 6. 49 cancel. 10 power minus 8. So when it comes to numerator, 4 into 10 to the power of 9. So 4 is my answer. Can be done. But this is the concept that should strike while doing the examination. 25 done, 24 done. Now I am working on 23. 23, time 11:35 is when I started. 25 plus 4, 29 minutes till now. Right, no issues. Focal length of a thin biconvex lens is 20. When an object is moved from a distance of 25 centimeters in front of it to 50 centimeters, the magnification of its image changes from M25 to M50, right? What exactly you wish to find? Here, 1 by V plus 1 by U is 1 by F. When the object is moved from a position of 25 centimeters in front of it to 50 centimeters, the magnification of the image changes from M25 to M50, right? First case, 1 by V minus 1 by 25 is 1 by 20. So 1 by V is 1 by 25 plus 1 by 20, 100. 1 by, final correct gaane chesaka. 1 by V minus 1 by U, 1 by V plus 1 by 25 is 1 by 20. So, అంటే ఇప్పుడు మీకు వచ్చేసేటప్పటికి minus 1 by 25, 1 by V plus 1 by 25 is 1 by 20. 1 by V is minus 1 by 25 plus 1 by 20. So LCM is 100. So minus 4 plus 5. So in the first case, magnification is 100 minus 100 by 25, which is minus 4 in the first case. Yes. Next case, 1 by V plus 1 by 50 is 1 by 20. So 1 by V is minus 1 by 50 plus 1 by 20. This is 100 minus 2 plus 5 minus or here minus 1 by 50 plus 1 by 20. 100 minus 2 plus 3 by 100. So magnification in that case is minus 100 by 3 times 25, which is 25 kada object distance 50 right? So this is minus 2 by 3. Boys, M25 by M50 is equal to minus 4 by minus 2 by 3, which is plus 6. So only one numerical pending. At what distance from a jockey? See, the problem here for me is I don't remember the resistance formula for a truncated cone. So if I don't remember formula, I need to derive. If I know formula, then there is no issue. Remember, there are three concepts: thick shell, truncated cone. You need to remember this. So the resistance formula for a truncated cone means like this. Remember, R1, R2, L. Then for this, we will write the resistance as rho L by pi R1, R2. Similarly, if there is a thick shell also, you need to remember that. Both you need to remember. Inner radius A, outer radius B. Right. Fine. Now the question is, it is 5 here, 10 here. So 5 by R1 must be 10 by R2. Total is 10, I know. In this case, hold on. R1 means rho into X is my answer. Pi R, left is R, right is 2R. Actually, this is a bit headache question. If you are at X location, the radius at that point, instantaneous radius is R1 plus X tan theta, where X, of course, is the same. Tan theta means R2 minus R1 by L. By the way, R1 is R, R2 minus R is small r, L is 10, right? So R intermediate, right? So pi rho X by pi R dash is 10 by rho 10 minus X by pi R dash 2R. Agreed? Fortunately, you can cancel these two. Fortunately, even you can cancel this 2 times rho. So finally, 1 by X. If you don't remember this formula, you are out. Your entire time goes waste. 2 into 2 by 10 minus X. So 10 minus X is 4X. X is 2. 2. Answer is 2. Right. Next. All integers are done. 100 grams of iron nail is hit by a 1.5 kg hammer striking at a vertical velocity of 60 meters per second. What will be the rising temperature of the nail if 1/4 of energy of the hammer goes in heating the nail? What is the kinetic energy part? Half into 3 by 2 into 60 into 60 is, okay, 1 minute. This is the total kinetic energy. And 1/4 of this is a mass specific heat, 0.42 joule per gram. Notice that it is in what will be the rising temperature of the nail? 3 by 2. 3 by 2 వేయకూడదు. Sir, your left side part is hammer, right? There is no mistake in this. 100 grams means you keep it in 100 grams only. 0.42 delta T. Done. So now you need to solve this part. So delta T is 3 into 36 by 16 into 0.42. I think I should send some good numbers in this. Any good numbers? 3 goes in 42. 14 times.
4, 4, 4, 4, 25.
ఇంకా ఇక్కడ 2 ఇక్కడ 2 తీస్తే 9 వస్తుంది ఇక్కడ. ఓకే 9. So 9 into 25 by 14. Now see the range of answers unnecessarily I am doing very vast. Sorry, bhaiya, see the 9 into 25 by 14 is undoubtedly more than 10. So this is the only option available for it. Options helped me a lot here. Then right. Now in this case, you take one element here, a small element here, d theta, and this is a theta. So the potential energy of an element here is mass per unit length times, okay, r d theta m g. H stands for r sin theta. And you need to integrate all such angles from what is this angle? Say for example phi. Phi is nothing but L by R. So integration is from 90 minus phi to 90. So what will happen here is M by L R square G sin theta d theta actually becomes minus cos, but you so finally this will become mr square G by L sin phi. Perfect. All surfaces shown in figure are assumed to be frictionless and the pulleys and the strings are light. The acceleration of the, see, very clear in this case, constraint relation says if this one is having an acceleration A, what is going to be the acceleration of this? Pardon? Paka? 2A. Very simple tension method. See, minus 2t times A is T times A dash, 0. So therefore, A dash is 2A. This will have 2A acceleration. And this is a tension. Now then, T minus 2 into G into sin 30 is 2 into 2A. Whereas in this case, 4Z minus 2T is 4A. So multiply the numerator with 2 times again and take the sum. In that case, 4G minus 2G is already 4 into 2, 8, 8 plus 4, 12A. So acceleration is 2G by 12 and G by 6. Remember, the acceleration of the block of mass 2 kg is what you want. Unfortunately, there is no G by 6 here. Fortunately, there is no G by 6 here. They are not asking A, they are asking 2A. So G by 3 is correct. Ball is dropped from the tower of height 30 meters and similarly B is projected horizontally at 6 meters per second from a tower of height 60 meters. A and B collide in air. Then find the separation D between the towers in meters. Remember what time it is happening, that I can determine. Because I need to take only vertical components here. 30 sin 53. 30 times 4 by 5. What is that? 30 times 4 by 5. 6 fours 24. So there is no vertical component and this distance is 30. So S relative is A relative, V relative times T. S relative 30, V relative 24. I'm speaking about a Y part, only Y part into T. So T is 30 by 24. Any good numbers? Paka? Seconds. Meanwhile, D is nothing but 30 cos 53 into T plus 6T. So, Bhaiya, this will become 90 by 5 times 5 by 4 plus 6 times 5 by 4. 5 cancel, 90 plus 30, right? 120 by 4, 30 meters. Correct. Done, 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 done. Right. No, even any other possibilities, let me check. Let me just check because time counts here. 19. Have we done the first question? Right. I'll try second question. The percentage of its stored energy dissipated after the switch S is turned to position 2. See, try to please understand half 2 into V square is the energy stored. You already know, you turn to the switch, you know already the expression for loss. This is the expression for loss, half C1 C2 by C1 plus C2. When two capacitors, one is charged, the other is uncharged, when you are connecting them parallelly, the loss in the charge sharing process is expressed like this. And one charge, initially the charge is this. So finally this fraction is going to be C2 by C1 plus C2. By C2 is 8, C1 plus C2 is 10. 8 by 10, 0.8. Percentage, 80 percentage. Do you know this or not? Where formulas ledu, will you derive now? It will take a lot of time. It is as same as two particles collide and stick together. What is the expression for loss of energy? Half M1 M2 by M1 plus M2 V relative square. Same, similar. Even disk over disk also same. Half I1 I2 by I1 plus I2 omega relative square. Same here. Three formulas which are common in three different areas. Done. 1 done. 2 done. 3 done. 4 not yet. Moment of inertia of a uniform cylinder of length L, radius R, about its axis perpendicular bisector is I. See, moment of inertia is I is equal to ml square by 12 plus mr square by 4. What do you want? What is the ratio of L by R such that the moment of inertia is maximum? No issues. Volume fixed, which is pi r square L. So where there is R square term, I will write V. Now moment of inertia is m by 12 times L square plus m by 4 times R square place. I will write V by pi L. Now di by dl 0. Andega. So which means m by 12 times 2l minus mv by 4 pi l square is 0. Right. Fortunately, you can cancel m 6 times here l cube is equal to 6v by 4 pi. 6 by 4 pi times, can you please help me in writing v again? Pi r square L, pi cancel. Finally, I got L square by R square is 3 by 2. So L by R is root 3 by 2. Done. Right. Time 12:23. Another 2 minutes. I'll struck 50 minutes barrier. Right. Done. A planar loop of wire rotates in a uniform magnetic field initially at t is equal to 0. The plane of the loop is perpendicular to the magnetic field. If it rotates with a period of 10 seconds about an axis in its plane, then the magnitude of induced EMF will be maximum and minimum respectively. See, please try to understand. You know already if this is the field direction and if it is rotating like this, then you know the EMF induced is BAN omega. No, it depends on the initial condition. Hold on. It depends on initial condition. For example, if this is the field and theta m bar cap. So in this case, you will write flux. Please help me in writing this. What is flux? Flux is BA cos theta. EMF induced is n time. If there are n number of loops, since this is a loop, there is no issue. Minus d phi by dt. This is BA. Arey bhaiya, theta is omega t. BA omega sin omega t. Okay, omega they have given. Here, so what is the graph says? This is the graph. T is equal to 0. The plane of the loop is perpendicular to the magnetic field, right? Here you are at T is equal to 0. What is the time period of this? 2 pi by time period itself is 10 seconds. So therefore, 2.5 seconds, 5 seconds, 7.5 seconds, 10 seconds. Combinations. You want maximum and minimum. 2.5, 5. Absolutely correct. So wrong option. Now wrong option and wrong. You need to check that also. Right. 7 done. Yeah. Any help, please? Only this question left, isn't it? Right. A quarter circle of radius r and radius refractive index 1.5 is placed on a table. A point object P is placed at a distance mr. Okay, from it. Find the value of m for which the ray from P will emerge parallel to the table as shown in the figure. Right. So the question is, when will it emerge parallelly is important. Because this is sufficient radius actually here. When will it emerge parallelly? You start in the reverse sense. So if you have a refracted surface like this, when will it emerge parallelly? 1. Mu2 by V minus mu1 by U is mu2 minus mu1 by R. Air, infinite, mu1, 1.5 minus U. I don't know where it comes from. 1 minus 1.5 by radius opposite direction, minus R. So finally, I can make it as a 3 by 2U is 1 by 2R. 2 cancel. U is 3R. So for an observer in this, it should come somewhere from 3R. Okay. So now, which means if I am in this reference frame, I should see that this is at a distance 4R. Actually, it is here. X distance. See, 4R by XR is the 1 minute. Now, the refractive index of the prism, no? 4R by refractive index of the prism is equal to
by A plus R by
no. U is 3R or R. 3R is from where? From here. So actually, U is equal to 3R, no? Or boss, U is equal to 3R. Backside, of course. 3R ante it's outside. See, from here it is 3R. So from here it is 2R only. So therefore, time is a criteria for me. If I am observing it, 2R is mu x actually. 2R is 3 by 2 MR. RR cancel. M is 4 by 3. Done. So you should start in the reverse direction. Where? Which one? 17 time. 16, 17. Okay. In the figure shown, see, this is the question which you should do last, undoubtedly. If not, leave it. Right. M1 50, M2 70, M80. Distance moved by the center of mass of the system with respect to ground. When nothing is moving, A should match 3. Okay, A matching 3 is possible in 2. Cancel all. Right. So, in the figure shown, when person A and B exchange, work right, no issues. Displacement of the, actually, the criteria is like this. M1 displacement of the man A. M2 displacement of B. M displacement of Planck 0. M1 displacement of the A with respect to Planck plus displacement of the Planck. Ignore my handwriting because I am fast wit. B with respect to Planck plus displacement of the Planck. M S Planck 0. Yes, I got it right now. M1 50 displacement of A with respect to Planck, the other side plus 2 plus displacement of the Planck. Hold, I will find that. M2 which is 70 displacement minus 2 plus displacement of the Planck plus 80 displacement of the Planck 0 by 100 minus 140. So minus 40 plus 50, 70, 120 plus 80, 200 times displacement of the Planck. So therefore, displacement of the Planck is 40 by 200, 4 by 20, 0.2. Displacement distance moved by the Planck with respect to ground. B1 distance moved by A with respect to ground is no issue. Displacement of A with respect to Planck plus displacement of the Planck. This is plus 2 minus plus 0.2. Correct hai gaide? Arya, please confirm. Plus 0.2. So 2.2. This 4. Right. My goodness. Done. Paper is done. So how much time that I have spent? Literally, in my watch, 12:33. Ignore for 2 to 3 minutes call, etc. like kind of disturbances, and I am discussing with you. In fact, this is also I'm indirectly explaining you. So therefore, in 1 hour, this can be done. If you do this in this particular order, obviously, materialization is high. Rather, see if we have done those questions which I have done last. Now tell me, will the productivity be high? No. So be selective, do like this.